The gentleman you see before you owns the Go Green Guy YouTube channel. Unfortunately, I do not know this person's name. I don't know if I've ever had a consultation with him. But what I do know for certain, and you guys will hear out of his own mouth, that he's using my information to stabilize his CNC controller after following the JD Garage CNC plasma plans and having issues. Let's listen to him explain what he encountered.
The JD's Garage plasma table build, and I got a lot of questions about the controller and the inside of it and the details about what I've done versus what the JD's Garage plans or instructions on the controller show you. So there was a little back and forth with Jordan from JD's Garage through the comments, and I let him know the issues, what was going on here with the grounding and what is ground and what is earth, or what is 5 volts negative. Ironically, and I've mentioned Corvette Guy 50 as well, and Corvette Guy 50 is zeroing in on the issues with the JD's Garage plans.
Hey guys, it's Vince. Today in this video, we are having a unique look at an end user who followed some information on my channel to implement on his own JD Garage Plasma controller build to rectify the EMI problems he was having. Now, what I find super interesting about this video, and many of you should, is that this gentleman, who unfortunately I don't know his name, I just know his YouTube channel is Go Green Guy. I recommend you all check it out. I'll put a link in my video's description for him. But it's so interesting that everything I've discussed about plasma systems or CNC in general being unstable due to EMI and what is being done with these plasma systems, especially them because they produce the largest amount, he experienced firsthand. He then rectified this by implementing what he's learned on my channel. We'll hear about this more. But I want to point out something that he just opened with in the video. And that is that he received pushback from one of the JD Garage guys named Jordan when he brought what he was learning to his attention regarding grounding. Now, many of you already know that earth ground and V negative on your power supply is not a ground. What he brought up is absolutely true. It's not a ground. And when he brought it to his attention, why did this gentleman not do his own research? Why would he instigate a pushback? It doesn't make any sense. Unless they don't want to be seen as wrong, because if they're seen as wrong by one, then others may see it as wrong and then act against that. So think about what I'm saying as we go through this video, because like I said, this is a very interesting video, a lot to learn here, and we'll discuss some things. He's definitely done a lot of work, and this gentleman does deserve everyone's support. And once again, I want to thank him. I did reach out to him to see if we could have a consultation talk. I wasn't going to charge him. I naturally just wanted to touch base with him and go over some things to clarify, because this video is quite long. It's about 47 minutes long, a lot to learn. I'm going to try to compress it as much as possible, just cover the explicit details that really need more detail on. But other than that, let's jump right in.
Now, again, mad kudos to JD's Garage for putting the plans together the way they did, electronically. Beautiful. Can't ask for better directions. And for the money, you can't beat it. As far as them being receptive to the issues that I've encountered and the corrections to it, with the help from Corvette Guy 50, check them out. If you're having EMI issues, like I did, terrible, freezing, kicking off, the whole deal. Machine acting erratically. You gotta. Those two go hand in hand if you're going to do this table. It's imperative that you watch it. So I want to go over some things here that I did again because there's a lot of questions about the controller itself and the grounding and the shielding. So we're going to pop the cover on this, and we're going to zero in on what I did. So as you guys remember, I cut a cover, a couple revisions, and we have our vent holes top and bottom. We're utilizing the fan from the power supply to blow out air here, and it's in line with the power supply, which you'll see once I pop this off, and it draws air through the bottom. Cold air, remember, cold air is heavier, so it always comes in through the bottom. Hot air will naturally rise out of a panel, a house, the highest point, right? So let's pop the cover off. Ooh, she's nice, right? So we did a way better job. So first and foremost, the metal enclosure is an absolute must. No plastic enclosure, okay?
All right, guys, what he did by mounting his power supply at the top of his electronics enclosure, and once again, the explanation he gave on where the cool air will enter from the bottom, the hot air will evacuate from the top, dead nuts on. The only thing that could make this the step above as far as best practice would be to install a cooling fan inside of his electronics enclosure. And he may still do that. That's a suggestion. And once again, just to be fair, this gentleman took it upon himself to install a mini split within his garage or basement, wherever his table is placed, as all of you should. Air conditioners right now are very cheap, and there is no reason you should be working in a non-climate controlled environment with your CNC production robot. I've said that before. Electronics do not like moisture. They do not like excessive heat or temperature fluctuations. Invest in being comfortable, not just for the equipment, but for yourself. You'll do a much better job. The next thing I want to address is what he stated about the electronics enclosure, and he's absolutely correct. This is right. If you notice, he doesn't have a coating on that enclosure. Why? Because if he installed a coating, it would mitigate the conductivity of that electronics enclosure, and that's why he went with bare aluminum. I'm assuming that's exactly what he did, and that would be 100% accurate. So looking at what you have here, we want a conductive enclosure with the lowest possible resistance. I'm not going to get into resistance. I'm going to let him cover that portion. But overall, what you're seeing here and what he's covering is exactly correct. You are not used to hearing me say that if you follow my channel at all. And this is something that I enjoy because, again, you can see what's happening. But best of all, it's the results that we're talking about. All these little steps, once again, work synergistically to make sure you get the result you're looking to achieve.
Our power supply mounted up top. Our fan right here in line with our door and our opening in our door. We have now a 5-volt power supply here. Right here, okay? This 5-volt power supply is now taking the place of the USB that we were trying to power and send data through right here. Okay, so now we have power supply for our drivers, power supply separately for our ESP32.
Now, I want you guys to pay very close attention to details. You notice how we have the main power supply powering our drives at the top of the enclosure. He also mounted the 5-volt power supply at the top of the enclosure. That's correct. Why? Because he's concentrating all of his heat generating components at the top where heat, once again, will rise, and he has the evacuation port right there to evacuate the heat. So think about what you're watching closely. Don't think that just because he didn't point it out specifically, that there wasn't a purpose behind mounting that where he did. That's a small power supply. I get that question myself a lot. Can I mount this here? It doesn't generate as much heat. The thing you need to look at is, once again, that word synergistic. And that means that it's greater than equal of oneself. So when you have a power supply here, or a power supply at the bottom, and another power supply over here, and something else going on over here that generates heat, you want to confine that heat to a specific location, preferably the top of the enclosure where heat would normally go, and then have the ability to evacuate as soon as possible. Very well done.
Okay. Now, the power coming in here is 120 volts, which right here we landed two sets of wires, two hots, two neutrals, and three grounds. Okay? We have a neutral and a hot going to our power supply, which powers our drivers. And we also have a ground coming in for this box. Just because this box is metal, I can tell you the resistance is different. So this box, it needs a ground. Don't rely on just the metal as the ground. Okay? Again, don't rely on just the metal as the ground. You have to ground this right here. Okay? So the other set, we have three grounds. Why do we have three grounds? Well, one goes to this power supply and guarantees ground. One goes to the 5-volt power supply. That guarantees ground there. And the other is grounding, comes down here, and it grounds what? Our enclosure. Okay, so now what is grounded? Boom, boom, and our entire enclosure is grounded. Okay, so
Once again, a very thorough explanation of how he grounded the system. Now, like he said, he's got his two power supplies grounded, and then he grounded his enclosure. And he checked for resistance. A plus. Why is he checking for resistance? Because just because you have continuity to ground, and I've said this in previous videos, does not mean your system is grounded. It must have a 3 ohms of resistance or under rating to be considered grounded. This is best practice, and this will assure that for CNC robotic applications, you have that technicality of being actually grounded. This is not a general application. You must follow those rules to assure that you have system stability. Now, one area of detail that he discussed, which is interesting, is he brought up that just because you have conduction on your power supply and it's making conduction to your electronics enclosure, which of course is metal, that you will still have resistance, which is absolutely true. And if you're determining that that resistance is high, like this gentleman did, then he did it correct. He mitigated that resistance by once again running a direct ground and then coming down, grounding the enclosure. And he just took and he installed the ground bus. We'll let him discuss it, but you can see there's a ground bus there. And all of a sudden, things start making logical sense. And that is, once again, worth explaining and once again letting him tell you guys for a change. But it's so interesting that this gentleman took this amount of time to rework his entire system. And we see it here. And this is an individual drive system. So once again, there's a lot of work here, a lot of time. And to get any type of pushback by a vendor who I think he's very lenient on myself. I myself feel like many of you, I'd be pretty damn pissed if I spent my money for someone claiming to understand a genre that they're selling components in just to find out that they don't know what the hell they're doing. Because looking at this, all of a sudden, and don't just look at this from the perspective that he did this work and, most of this work wasn't required. He did this work because he found he was having issues. Had this work been done correctly the first time by JD's Garage providing the correct information, this gentleman would have never had to go through this. nor would many of the other people who I'm sure purchased these plans and have gone through the same hell. Hey guys, jump over to eDealers Direct Automation and check out my eBay store for the components used to make what you see in this video, as well as many others that you may not even realize you need. Of course, I'm always there if you have questions. Message me and I'll get back to you as soon as possible. And of course, I do custom engineering as well as consultations. Thank you for watching this video and your support. Take care.
Any interference picked up by this metal enclosure is going to be sent to ground. And we're going to talk about that in a minute. Because we're sending ground, we're going to send that interference in two different directions. We're going to send it to the ground, the grounding rod that we have set up, and we're going to send any interference here through the ground from our 120 volt power supply. Okay? Now, to eliminate the daisy chaining that's been going on and caused a lot of problems, what we did was we took our 5 volt power supply here, okay? We have our 120 volts coming in. That's the black, green, and white. And then we come out of this, the 5 volt power supply, with a 2-wire, which is a black and a red. We bring that black and red down to here, and we create and we install a positive 5 volt bus, and then at the bottom we created a 5 volt negative bus. Negative bus. It's not ground, it's not earth. That is the issue. Okay? That's issue number one. Number one.
Once again, this is super interesting. He's discussing using a terminal splitter on his 5 volt power supply, probably because the 5 volt power supply, like so many of them, not designed for CNC use, have a limited number of connections. And he realized he had multiple connections that he wanted to hook up. So what did he do? He used logic and he said, I need to split these connections into multiple connections because that's best practice, so I avoid daisy chaining. And he brought that term up as well. Once again, he's been paying close attention, and this is once again done correctly. And you will hear him explain optimization overall. This is exactly what should be done on all systems. And it's also why I designed my 48 volt power supplies, once again, to have a 10-point power output terminal block on V positive output and V negative output. So you don't have to go through installing these terminal splitters as this gentleman did. Because again, aside from the cost of these components, because guys will say, oh, well, that's cheap. It's not that expensive to do. They're right. It's really not that expensive to do in terms of cost, but like so many other things, when we determine cost, we also have to determine our time and factor that time in, and also understanding the knowledge in order to do that. And this is once again where I say we really have to start holding these people who are putting plans together, systems together, whatever they're doing, they have to be held accountable to make sure others don't get burned. Because if we are not holding them accountable, this kind of stuff where an end user is essentially educating someone who's selling these components, which, as crazy as that sounds, is exactly what's happening, it will never end.
That is not ground. You don't put your shields on the negative of the 5 volt bus. Okay? Your grounds go to ground, which goes to earth, which is the green. The green. The panel. The enclosure. Okay? Now, this is independent. Why do we want it independent? Because we don't want interference draining into our 5 volt negative. Okay? Why? Because the 5 volt negative only powers the ESP32. We don't want to drain EMI into the 5 volt negative, which is not ground, it's 5 volt negative, back into the controller somehow. You will loop it back. Okay? So these two buses are completely separate. Why do we have the buses? We had the buses to eliminate all the daisy chaining that was going on in the original plans. That's why we have it. So we have 5-volt positive here, 5-volt negative down the bottom. We have, as you can see here, the heat shrunk line right there is the main line coming from the 5-volt power supply. Same down the bottom. Okay? And then from there, we know the 5-volt positive is all through this bus bar. 5-volt negative is all through the bottom bus bar. So anything that needs positive or negative 5 volts is going to come from this bus bar directly, not daisy chained. So as you can see here, all of the reds are all the 5-volt positive that we need for all of our relays, and they're all individually ran from the bus. And you can see on the top here, one is probe, one is Z, Y1, X, so on and so forth, whatever. And then we have the relays here, which are powered, what? Directly from the bus to the relays. Directly from the positive 5-volt bus, directly to what we're trying to power. That includes the ESP32. That power comes directly from the bus, right to the ESP32. Nowhere, anywhere in this panel, you will find a ground that is picking up interference sent to the negative 5-volt power supply. It's not where it goes. Okay? That is not ground. So, we have those buses there. Okay? Now we also have all of our power up here, feeding our drivers with our bus right here. See that? No longer are they daisy chained, because originally in the original plans they were coming out of one driver into another driver, out of the driver into another driver.
Well, I told you this video would be different, and it certainly has been. But we all have to ask ourselves, when do we now hold accountable these vendors for wasting everyone's time and money providing misinformation? Why are they being rewarded? It makes no sense. If somebody steals from you, are you going to give them more money? It just, I mean, that's essentially what's happening. Oh, it's okay. You'll learn later. Don't worry about it. Just keep selling. It's okay. The sales are the easy part. It's understanding the tech support that goes behind the sale. I could sell components all day, guys. Do you really think that would hold me back? I've had guys ask me that all the time. Why aren't you selling this? Why aren't you selling that? I only sell what I support. So when you see 400, 500 items in my store, that's 400, 500 items I've either designed or mastered to where I can support it at a level that I feel comfortable you'll get the result you want. Think about that. Now, if I was unscrupulous and I didn't give a shit about who I was affecting, I would have been a millionaire a lot sooner than I am now. Okay? But I'm telling you the truth. And here's a fact. No one person is hated more than the one who tells the truth. What we're seeing here, is this the truth? Is this what his truth is? Because the vendor, and this is where I want you guys to think about this, if the vendor is telling him to connect his shield drains from his cables to the V negative on the power supply, and this gentleman called him out and said, Jordan, no, that's not right, and he gets pushback, wouldn't it be logical that that guy go back and check and make sure that what he's saying is accurate? Never was done. Or he doesn't want to admit to it. Whichever way, we're seeing a line of ignorance here that is hurting people. And if you're being defined as hurting people without taking accountability for it or correcting your actions, I would justify that as being evil. You call it what you want. I don't know what the purpose is. There is none. I think of this and I look at this, and the amount of work I'm seeing here is pretty ridiculous to correct mistakes made in good faith of him paying someone to provide accurate information. And once again, the student has become the teacher. Now, I want you to think of how crazy this is, and think of how many of you have been burned in similar situations. It's really, really sad. And I know many of you are watching this, and I want you to think of this. Many of you who leave the stupid comments and say things, oh, well, be easier on them. Should I? Should I really be easier on them? Or should I try to bring them up to my level? And when I say my level, I don't want to treat you in business any way I would not myself want to be treated. Remember that old rule? That one biblical rule? That's the only rule you really need to know, is treat others the way you expect to be treated. Is that what's been done here? How many times has it been done to you? Think about that. In anything, just anything in life, think about that. We look at this and it's amazing. This guy has gone through all of this to correct something that should have been provided from the get-go, as that's why he paid these gentlemen, is because he found them. If he would have found me prior to that, and I'm assuming that's the case, that he didn't, because most guys find me after, most of them would at least say, hey, let me research what this guy is saying. Pretty crazy.
Out of the driver into another driver. That is no good. Nowhere on here, anywhere, are you going to find any daisy chaining going on. Okay? That is no daisy chain. You can go see Corvette Guy and he'll tell you. No daisy chain. As you daisy chain, if you have a loose connection or a poor connection at one point, you have it going all the way throughout that circuit. The problem is with that is you can't diagnose properly. You can't zero in on an individual piece of this. Because if you have a problem here with a connection, you daisy chain off of it, you may experience problems with the other three drivers. You might think you have bad drivers, but you don't. You have a bad connection in the beginning. And because it's daisy chained, it starts from the source. If it's bad, if it's a bad connection. Could be. This way, you can actually test from the bus to the driver. All the stuff over here on the 5-volt, positive and negative, same thing. From the bus to whatever device you could check individually. Daisy chaining, no good. Okay? So what else do we have? We have up here a full grounding bus. Right here. Okay? Now, you can see from all this here, we have a grounding bus here, and we have a grounding bus here. This is a ground bus, a true ground bus that eventually goes to Earth. How do we do that? Well, we pulled one of our grounds, that one of the three up top, and then we send it to this bus so it can pick up interference and send it back. So this is now a grounding bus, and then you can see we jumped from here, from this bus, we jump to the enclosure itself, and then over from that enclosure we have another grounding bus. So this is an area to drop any shielded cable to drain EMI, and this is an area to drain EMI. Now, if you look at our driver wiring, right, we heat shrunk everything real nice, nothing's exposed. We have these are shielded, right, because they're for our drivers. Our shielded cable comes up here. We pick it up with in this case, we picked it up with a green sheathed wire. It's regular grounding wire. We soldered it and heat shrunk it to our the shielding part of the cable.
So now we see that he has two ground buses in his system. And guess what? That's fine. You know why it's fine? Because he followed best practice. He took a ground bus where he's splitting a single point of ground, utilizing what's known as a star point grounding system. That's the technical term for it. And he split it properly with a ground bus. And then he took another location, a terminal location on that ground bus, and added another ground bus wherever he decides to make it more convenient. And guess what? That's fine to do. He is not creating a ground loop. He's not doing anything that would mitigate that system stability. He followed best practice. This is more work. And once you guys see this, you would understand those who've done this, like this gentleman. I would love to hear how much time it took to do all this. Not the money so much, because you know what happens is people get lost in the fact that they've already spent a lot of money and now they're at a point where it's like, look, I just want to get this running. I have a giant paperweight. I can't tell you how many guys I've run into like that. But I really want to know after the smoke clears what they value their time at. And that's what I always find interesting. When guys ask me, why do you charge what you do? Well, you don't just buy components from me unless you don't want support. So I know you're going to want support, especially at one point or another. And therefore, I have to price my components not just on the component, also on the support. And then is there labor involved? So you look at all that, and then it starts making sense. Well, when I look at this, you have to ask yourself, if he corrected a build already, how much time do you think he has in this? If he decides to add another ground bus, now he's doing all those connections. And of course, he's avoiding any type of daisy chaining. He's already eliminated that in the system. So there's a multiple connections there. Think about that. He's already covered now his shielded cables have a shield drain that's soldered on. He used a green lead allocated to grounds. Very simple. You guys don't want to label your system, that's fine. Always use different color wires. Why? Because you know that those wires are going to dictate how you built your system, or they should. That's the logical way to do it. And of course, green is always ground, typically. So when we look at that, everything he did here, spot on. Spot on. He's thinking, he's learning, he's saying, you know what, this makes sense. And you know what tends to happen? I get guys that tell me this all the time. I watch your videos, and at first I watch them and I don't get it. Then I start building my system and I see how you think, and then I get it. You see it right here.
And then we took that shielding and we're draining it where? To ground. We're not draining it to the negative 5 volts. Don't drain anything there. I'll say it again, I'll keep saying it. So up here, because it was closer and it looked neater, I drained all of the cables, all the shields for the drivers. I drained up here at this grounding bus. Okay? Beautiful. Works out great. Now, down the bottom here, because it was closer, that's why I set up this other grounding bus. You could see these are all the probe Z, Y1, X, Y2. That whole bank, right? And again, we have all these powered from the 5-volt bus, all of the other side powered from the negative 5-volt bus. And look at this. All the shielding from every wire is going where? To our ground bus, which is here. And I located here because I wanted to keep these short, right? We want it to drain away. So any EMI that's picked up from any of these limits or probes, switches that are on the table is going to get picked up through the shielding, and it's going to drain through the ground and out from our 120 volt power supply where our ground comes in. Okay? So now this enclosure, metal enclosure, is grounded. So if it picks up any interference from outside, it's going to soak it up and it's going to send it out to ground. Same thing with these limits switches here. Okay? Now, if I could have heat shrunk these and just left the ends, attached.
All right, guys, I'm going to make a suggestion to this gentleman as well as all of you. Anytime you have a bare conductor inside of your electronics enclosure that you assembled, and you heard me say you assembled because you're liable for that controller, you always want to use an insulator, preferably heat shrink. And the reason we do that is because, God forbid, there's ever a fire, and I've said this in previous videos, that your insurance company, when you contact them and they send the fire marshal out and they have any type of investigation done on where that fire was started, they would never look at your system and say that something there was wrong that instigated the fire. Because remember, the ultimate goal of your insurance company is not to pay. Remember that. That is what they're here to do. Don't let this bullshit start where you're watching State Farm commercials and everything else on TV and all these insurance companies got your back. They have your back when they have to. Remember that. And that's it. That's exactly the way it works. We all know that and should know that. And that's why I say if you cover your ass in the beginning, you don't have to worry about covering it at the end. So just think about what I said.
which I still might do, but six of one and a half dozen the other. It's going to drain to ground. Okay, that's the main thing. Get the interference that's picked up from the cable, and send it to ground. All right. So pretty cut and dry. These are. It takes a little bit of time because you have to get this stuff. Don't just throw it in there. You know. Try to keep the cables as short as you can. Right. And you know, make a neat job wherever you can shrink wrap and heat wrap and, you know, do the ends here, solder the ends. That's great, you know. So this bus here, I failed to mention, this is a 3v3 bus from the controller. So this 3v3 was originally, this is the one that was jumping from drive to drive to drive. Right? It's a 3-volt signal that comes from the ESP32. So I needed a minute I was having a brain fart there. So this is a 3v3 bus, which eliminates all the data. If you could see here, this is a 3v3. It comes up here and it feeds like right in the center of this bus. And that makes this whole bus 3v3, 3 volts, right? Which initiates the driver. And then off of that is where we get our 3v3 to send to each of our drivers. That's the red wires on each of these. Okay, again, this eliminates the daisy chain. So how many buses do we have? We have a 3v3 bus. We have a 5-volt positive bus, a 5-volt negative bus, and 2 grounding buses, strictly for our shielding. Again, these are strictly for our shielding. We're not taking never are we taking the 5-volt negative and mixing it with the grounds. It's not the same.
All right, guys, so this is once again why I explain I prefer an integrated drive versus an IDS system. Let me define it. What you see here with this 4-axis system, we see 4 CNC drives, therefore it's 4-axis. Each drive incorporates controlling a single axis, so we have 4 axis. Now in his particular instance, he most likely has a slave configuration on his Y-axis, in which case 2 of those drives are allocated for driving his Y-axis. The thing to keep in mind on an integrated drive system instead of an IDS individual drive system like he has here, everything is integrated in the drive. So the motherboard of the drive that has all of the individual drivers that plug into them, it takes care of the majority of wiring and labor you see right here. So you kind of have a choice to make. And this is what I always project to my clients. If you want to build a system because you have a specific purpose or the fact that you're in a realm where you don't have the money, then an IDS system is definitely going to be your best friend because you'll invest your labor, which is sweat equity, to get your system built. It'll be a cheaper format in the sense that, yes, you're going to be buying individual components. And a lot of guys go, well, you know, it's cheap for me to buy these components. And I always beg to differ with them. By the time things are said and done, usually you end up spending more because you need to do so much customizing. When you buy an integrated drive system, you pay the money up front, but the drive itself has the majority of features required that will get where you want to be. Gecko G540 is probably the base level integrated drive. Then I've got the SMCU4 from Audio Ohms, which I helped design, and that has integrated relays, 2 of them, along with a plethora of features that are already standard in the G540. So the real question here is your budget. What do you want to do? What he's explaining here with the splitting of the terminal blocks, the majority of that is eliminated when you're working with an integrated drive. Once again, labor here really has to be looked at because each lead, if he's doing solder connections, I'm assuming he did, each lead has to be soldered, and that means solder, flux, do your lead, move to the next. Solder, flux, do your lead, move to the next. And when you're doing a custom system, that means you're also measuring each lead. Each lead has to be cut to a specific length. Like I said, this is certainly not my first rodeo. I've done many of these systems. There is quite a bit of time that you are investing. And if you're all right with doing that, that's fine. But I cannot emphasize enough, before you spend your money, be very careful on how much you're going to actually spend and what's available. Because a lot of times, integrated drive systems will beat this.
That is the conversation that I had with Jordan in the comments, and he said there are no problems. So I'm just here to help. This will help a lot of people. It'll get your table working consistently. It's going to make your plasma cutter cut better. The plasma coming out is going to be sharper, cleaner. It's just all around better. I mean, the table itself has done nothing but perform for me since I've done all this. And no longer do I dread pumping a file into this and crossing my fingers and hoping it may or may not work, because that's what was going on, or I was going to waste a piece of material. Who wants to do that? Because at that point, the amount of money that you're saving on the table, you're going to burn in material. Let's face it, metal, sheet goods, they're not cheap. You know, especially if you're cutting aluminum or stainless, you don't want to mess up anything like that. You want it to be cutting, you want it to be cutting correctly, consistently, and without any interruptions or hiccups. Now, another thing I want to show you is the ground and how it functions on this table and how we dissipate the EMI from it. Now, we're going to look on the back here, and I'm going to show you the back here. We have isolation blocks. These isolation blocks keep the ground, the table itself is grounded to the grounding rod directly, which is that cable right over there. I'll show you the grounding line. Right now I have the table pushed all the way up, but we're going to move it because we're going to do some resistance testing, and we're going to show you what exactly is happening and an explanation. So we want isolation between this ground, which is going back through our 120 volt earth ground, okay? Because that's where it eventually goes. It goes through that 120 volts, out that ground, and then it goes over the electrical panel over there, and then that electrical panel is tied into a ground rod that goes into the ground over there on the other side of the garage. Okay, now why do we do this? Okay, there is something that people talk about in grounding and wiring, and it is resistance. So think of resistance as traffic, right? If you want to get somewhere quick, you don't want to go on a road with traffic. That's essentially what resistance is. So when you have resistance, that's why Corvette Guy 50 always talks about you're looking for 0 ohms of resistance, because 0 means, look at it as cars on the road. At zero resistance, there's no cars on the road. Whatever you're trying to dissipate through ground will go right through it. And that just doesn't apply to ground. It applies to electricity too. Because the more resistance you have, right? Think of it this way. when you're sitting in traffic, what happens? You get heated, you get angry, you rage, ooh, right? You want to get out of traffic. People, you know, that's what traffic is. That's what resistance is. Resistance is there's too much stuff on the road, whether it be from a bad connection, we'll call that a bad driver, or a bad exit, or a closed exit, as an example. So here is the concept behind this and keeping it isolated, the two grounds isolated.
His analogy of traffic jams and using that to explain resistance is probably one of the best explanations I've ever heard. It's a really, really great way to make everybody understand just how it works. And he is absolutely correct. The lower the number of resistance, 0 is optimal. If you can hit 0, fantastic. 3 or under, you're right on. Certain applications, you'll have slight resistance, dealing with different types of metals and dealing with a lot of different contact points. That's possible. So shooting for 0, you're never going to go wrong. I've had some clients get under 0. You can get negative numbers as well, which is amazingly fantastic. It's all about reducing, as he said in his analogy, traffic. We want that dissipation of energy to happen virtually immediately. The faster it happens, the more stable of a chassis you will have. And that's regardless of a plasma or just a mill, whatever it may be. This is imperative for you guys to understand. Everything here is being spoken about with a plasma CNC robot. However, it's universal. These robots deal with the largest amount of EMI, which means if you have a router or a mill, you should still be following these practices. The difference is you're not dealing with such high levels, but the principles are exactly the same.
And what we're going to do is we're going to take a reading from this ground to the table ground. And you're going to see a massive amount of resistance. Okay? Why do we want that resistance? I'm going to show you. It's a pretty good meter. Now, just as a practice, just a quick, we're going to go from this ground, which is our 120 volt ground, to our panel, to our enclosure, which we have a resistance of 0.1, which is technically 0. It's nothing. So I don't have any traffic between my ground coming in and my enclosure. That's what we want, right? Now remember, this panel is isolated from the grounding rod that the table is grounded to. Now I'm going to show you. Let's try from the outside of the panel, okay? Let's go from the panel to the table. The table ground here. Look at that resistance. Okay? We have, and climbing, 320, 330. So we have, it keeps climbing. The resistance is high. Now, here's the theory behind this. There is a lot of resistance between the two. Okay? Which means there's a lot of traffic and cars on the road between this ground and that ground. Okay? Now, any EMI that's picked up from this area wants to take the path of least resistance, which essentially is this ground. And it's going to go this way, right? Towards the panel. And because there's so much traffic in between this ground and the table ground, anything picked up by the table ground is going to go directly towards the grounding rod, because there's so much traffic between these two grounds. Okay? If you start joining the two and you try to drain one into the other, you're not going to dissipate the EMI.
All right, guys, I just want to be very clear, as I believe our friend here is on the right path. I just want to make sure everyone out there understands exactly what he's explaining. What he's talking about, where we have a ground rod for our plasma chassis, that is optimally the best way to go whenever you're dealing with a plasma system. It's not always practical for all end users to do. If you can do it, by all means do it. It's going to make a huge difference. Now, in his case, he installed the ground rod in the closest proximity to his plasma chassis. That's going to lower resistance inherently because proximity, close distance, if we shorten our distance, we can get to ground faster. Common sense. If we're using a heavier gauge conductor, meaning wire gauge that is lower, a 1 gauge wire is naturally going to produce lower resistance than 18 gauge wire because 18 gauge is thinner. I recommend always using ground strap, which is used on railroads, and you can pick it up in different gauges. I do offer it myself, and that's optimal for grounding, especially plasma systems. Now, if we shorten our distance to that ground rod, regardless of what we connect to the ground rod, pending we measure our resistance, it's irrelevant what is connected to it. Your resistance, the traffic, like he said, it just depends on what that resistance is. It doesn't matter what's connected to that ground as long as it's hitting Mother Earth and can be dissipated as fast as possible. Henceforth, that's why, once again, we want the lowest possible resistance, which would be, that's right, you guessed it, 3 or under. Now, under most practical circumstances, when you are plugging your power supplies into your wall outlet, henceforth, like my system's IEC power port, it gets plugged into your wall outlet, you're going to have a ground that's coming right out of your wall outlet. And if your home or building or whatever facility you're working in has a proper ground, you're going to find that resistance is going to be very low. And if you take that measurement of resistance and it's low, naturally it's more practical to use that as a ground for your power supplies or your electronics because it plugs directly into it. Meaning that's typically where you're going to plug from the source of your wall outlet to your electronics enclosure. It's really, really simple when you think about it. So we have our ground rod. In this individual's case, he's got it once again allocated to his plasma table. And then he has his electronics ground, which once again is running over all the way to his breaker box, which most people will have done. So again, the only possible confusion would be that there's a problem with resistance if you were to connect the two. Now, there are times you may have too many connections going to ground. If that's what he means, he's absolutely correct, and that you're getting a higher number. But typically, the more connections going to ground don't always indicate a definitive high resistance level. It depends on a couple different variables. And mainly what it's going to depend on is what exactly is the distance. Distance plays a huge role. And then, of course, conductivity of what we're using and what's that proximity, once again, to that ground rod or that breaker box. So thinking about what we've just said here, once again, I just want to make sure everyone's on the same page. He's on the right track. And again, he's done the work. I mean, there's a lot of work done here, guys. And I don't care. He can play it down. I think he's kind of selling himself short. He did an enormous amount of work. Rebuilding an entire controller is not easy. I want to sum up this video because this is the portion that I wanted to get to and just make sure we cover all bases on. There's, as the video goes on, he covers that the system is working great. It's completely stable. You heard him say it. He did discuss that he's having issues cutting circles and certain, I guess, them being round. Typically, that's due to axis calibration. It could be due to other things, but axis calibration is inherently important and must be done with precision. I have videos covering this. I hope he finds it on my channel. I hope he reaches out to me. I've reached out to him, like I said in that comment. I haven't heard back as far as scheduling any talks. If he wants to discuss it, we can
And now when
discuss
we
it.
go
But
back to 0,
right
we should
here,
actually hit
putting it
0.
on screen, you
That
can see it
much
being
didn't take
done.
a little
James is a
bit to
past
do.
client of mine,
So
and
we're
he
just going to
covers
keep doing
access
this a few
calibration with a
times.
G540 system. However, the process is inherently
Make
the
sure that
same
we're
on
within that
whatever
point oh 0.01
system you're
every
working
time.
with. The thing to keep in mind is this. When doing access calibration, and I've said this in so many videos, when you calibrate to a 1 inch measurement and you have a differential, excuse me, if that differential is, let's say, arbitrarily 3 thousandths of an inch, that means for every inch of travel, you're going to have a 3 thousandth of an inch variable. So depending on the size of your table, you have to multiply that variable. And once again, that inaccuracy is multiplied towards the length of the table, or at least the size of the table, in which case you'll be machining in that machining area. So, excuse me, once again, this is critical to understand. A lot of guys do a 1 inch calibration, and when they do that 1 inch accuracy calibration to the axis, they assume that everything is good. Usually it isn't the case. And where you usually find it is in systems, unfortunately, where we have a lot of parts that are not optimally built with high precision. If we have a linear rail that once again is one piece, and we're not using parts that are potentially off, the more that part has a variable, you're going to see that carried over into axis calibration. Fact. So these are areas to consider. Low price chassis, 3D printed parts, more potential for inaccuracy when we do axis calibration. Low price drives or low voltage components such as USB controllers, I believe this is called an ESP32, you're going to have a very high susceptibility to EMI interference. I'll put the email here from Balzas on screen. You guys can see what happens with USB. The one area of concern I have, and it's pretty much the only area of concern I have in this entire video, is the fact that he's had such great results, but I have to say it because this is where guys go wrong the most. They feel that because the system is stable, even though they're using a USB controller, however many cuts he's done so far, the system has been stable. However, they've determined that stability as now that the system is completely stable. Remember, a table is only as stable as the amount of cuts that have been performed and the duration of those cuts. So if you have an 8-hour cut and that's the longest cut time you've ran the table and it's been stable, well, that's the length of stability you have. But do not believe that because it was stable yesterday, that it's going to be stable today and your odds are just as good as yesterday. This is the biggest misconception with plasma systems or CNC in general when it comes to troubleshooting and not following best practice. In this particular instance, what I'm discussing is that USB controller, even though it's been stable to this point, he can't say tomorrow it's going to be just as stable because it's a weak variable in the system when it comes to control signals. We do not know what level of EMI, we do not know what level of anything is going to potentially cause that unit to crap out in the sense of where it'll lose signal. And that's exactly what happens with USB, and it's exactly where they're most susceptible, especially on plasma systems. This is why I call it the skydiving effect. You have that skydiver who believes his odds are better every time he goes and jumps. It doesn't work that way, guys. There's no experience in skydiving. You strap a chute on, you check your chute, you bail out. If your ass hits the ground, you're done. That's it. It's over. Don't sit here and act like because you did 200 jumps before that, somehow things made it so that that next jump you have more experience because you did 200 jumps before. It's bullshit. And anyone that tells you that is as ignorant as those jumping out of a perfectly good plane. Think about it like that. Fact. Respect the unexpected. And when I say that, that's where guys typically want to save a buck. They cut this video off early on. The guys that are serious will watch my videos through because they get the message. And that's what I'm telling you. That's the only area of concern I really see with his system, other than Once again, as I brought up axis calibration, that will definitely help him. I hope that's the issue it is. And last but not least, I did notice that after I watched his video, he is using standard electrical switches. If you're going to install switches on your system and you're running a plasma system and you're using a water table, you must install, in best practice, waterproof switches. Pure logic, guys. Pure logic. A lot of guys, and I think he may not know that he exists. So once again, these are things to think about and purely logical. You do not want to run standard switches because over time, moisture gets in that switch. And believe me, splashes happen all over the place. When it happens, what will end up happening is you may know or you may not know that switch failed. If you know, you can correct it. It's still a lot of time, but you can correct it. If you don't know, and that machine crashes, that could be catastrophic, especially when you have a job on the table. So again, I hope that this video has been helpful. Once again, I'm sorry I don't know this gentleman's name, but he did a fantastic job overall. And I like doing a video like this. It really breaks me out of that rut of always discussing what somebody did wrong. This gentleman, I don't know his name. I don't think we've ever had a consultation. I'm telling the complete truth here. He doesn't have any of my components in his system. He's just following, I believe, what he saw. As a matter of fact, his Fluke multimeter looks very similar to mine. I believe it might even be the same model. But either way, he did a fantastic job. I wish him all the best, and I wish you all the best. Thank you all for your support. Take care.